From the ancient time, humans have fascinated by the invisible forces in nature. For instance, in magnets, why do same pole repel each other and opposite pole attracts? And in this video, I will take you to the journey from ancient static electricity to the most modern explanation of those invisible forces, that is, the quantum field theory. All started from when ancient people rub amber with silk cloths, and when they bring the amber close to small paper pieces, the paper pieces get attracted by the amber, and later on it is explained by the Coulomb force, which you have studied in your high school. And later we studied this electricity and magnetism more intuitive way, and thus we built the classical electrodynamics, which is mostly governed by Maxwell's field equations. Here, particles and fields are two distinct concepts. Particles, like positively charged particles, create electric field, and if you place a small test charge within this field, they will experience an electrostatic force which mediates through these field lines. But later on, we merge classical electrodynamics with quantum theory, and we get one of the most beautiful explanation of those invisible forces and interaction, and that is the quantum electrodynamics. And Richard Feynman is one of the founding fathers of that beautiful theory. In quantum electrodynamics, we explain this interaction by exchange of virtual particles like photons or gauge bosons. To understand the exchange force, let's take a simple example. Imagine two people are standing on two small boats freely floating on water, and if person 1 throws a heavy ball to person 2, what will happen? Due to the conservation of momentum, they will get pushed little by the ball, and here the ball is transferring the momentum, and the resultant motion is considered as the repulsion. And also, this ball is the one which is mediating the force or the momentum. Now consider that we can't see the ball, that is, it is invisible. Then from the external point of view, we will consider these as mysterious invisible force, just like the invisible electrostatic force. Now take this analogy to electrostatic repulsion of two electrons. And here the virtual photon is transferring the momentum just like the ball. And this can be explained better way using Feynman diagrams. Now come to the last part, that is quantum field theory. When you delve deeper into the quantum electrodynamics, you see it's a simplified approximation of quantum field theory. In the quantum field theory, particles and fields are no longer distinct concepts, but they are the same concept, where the particles are the result of ripple or fluctuation on their respective fields. For instance, electron is nothing but the ripple in electron field, and photon is a ripple in photon field. And we call the interaction or forces is actually a coupling between these fields, just like mixing two different soups, and you get a result which can be considered as attraction or repulsion. And this interaction is described using this equation. So that was it. To study these things better way, You need to study the quantum chromodynamics, particle physics, and more. And we will see you in the next one. Till now, take care and keep studying.